All right, next we're going to look at gas laws. We just looked at gas laws, and now we're looking at gas stoichiometry. So on your test, this is a different section. For gas stoichiometry, it's all about how 1 mole of gas equals 22.4 liters of that same gas at STP. So you'll notice that both of these questions will say at STP. So let's read. How many moles of O2, so oxygen, are needed to react completely? So I'm looking for moles of O2 are needed to react completely with 52 liters of CH4 at STP. Remember, at STP, 22.4 liters of a gas equals 1 mole of that same gas. So, how many moles of oxygen are needed to react completely with 52 liters of CH4, which is methane, at STP to produce carbon dioxide and water? Grade your answer, so you'll have a gradable kind of like this. So what you'll do is you will use the guess method because we have 2 molecules or we have 2 gases. That means I need to know my given, my unknown, and my E. My given is the number given to me, so 52.0 liters of CH4. My unknown is moles of oxygen because that's what I'm looking for. Equivalence. Well, equivalence would be I have 2 different molecules. Because I have 2 different molecules, we need molar ratio. And we use unknown over given. So that means moles of O2 over moles of CH4. And this comes from our equation. So I pick out moles of CH4 using my coefficients. So I have 2 moles of CH4 for every 5 moles of oxygen. Well, that doesn't get me rid of the liters, so I'm also going to be using 22.4 liters equals 1 mole, and I can switch this either way. Next is my setup. We always start with our given. The given is 52.0 liters CH4. Now that I've used it, I can't use it again. I want to cancel out liters of CH4, so I know liters of CH4 is at the bottom. Well, my molar volume, 22.4 liters, tells me I can use liters and moles here. So I can go from liters to moles of CH4. So I'm going to have 1 mole of CH4 at the top because I know that for every 1 mole of CH4, I have 22.4 liters of CH4. Remember, once we've used something, we can't use it again. And then I have to ask myself, do units cancel? Liters and liters of CH4. Yes. Moles of CH4? No. Is this my unknown? No, so I need to go to moles of O2. So that means I still need to cancel out moles of CH4. And I'm going to use my molar ratio now because that's the only term left with moles of CH4 in it. So I have 2 moles of CH4 for every 5 moles of oxygen. Use that, can't use it again. Let's double check. Do units cancel? Moles of CH4 does. Are we left with our unknown? Moles of O2? Moles of O2, yes, that means I have the right setup. Remember, top line multiplies, so it's 52.0 times 1 divided by 22.4 times 5 divided by 2. So I'm going to use my calculator to solve for that. So 52 times 1 divided by 22.4 times 5 divided by 2 gets you 5.80 moles of O2. Next one. The reaction below is an important step in the industrial production of nitrous acid. 2NO plus O2 yields 2NO2. Measured at STP, remember at STP I know 22.4 liters equals 1 mole of a gas. How many liters, so I'm looking for, this is my unknown, liters of oxygen will react completely with 1 mole of NO2. So that's my given. Remember, stoichiometry, given, unknown, equivalence, and setup. Given is 1.00 mole NO2. Unknown is my liters of oxygen. Equivalence, well, I see that I have two different molecules, so I need a molar ratio. So it's unknown over given. So moles of O2 over moles of NO2, which comes from my equation. I have 1 mole of O2 for every, 2 moles of NO2. Since it has liters of O2, that means I need to have 22.4 liters of O2 equals 1 mole of O2. Next is my setup. Always start with your given, so I'm starting with 1.00 moles of NO2. Used it, can't use it again. Now I want to cancel out moles of NO2. I'm going to be using my molar ratio because it's the only thing with moles of NO2 in it. So 2 moles of NO2 for every 1 mole of O2. So cancel that out. Do units cancel? Moles of NO2 does. Am I left with my unknown? Moles of O2. Does that match liters of O2? Nope, so I need another term. So moles of O2 will go at the bottom. I know that for every 1 mole of O2, I have 22.4 liters of O2. So I've used that term. Do units cancel? Moles of O2, moles of 2? Yep. Am I left with my unknown? Yep. So I have my right setup. So next I'm going to multiply 1 times 1 divided by 2, because 1 times 1 divided by 2 times 22.4 divided by 1, and that gets me 11.2.